Good morning, students. So let us resume our discussion on chemical bonding. In our last session, we discussed about what is hybridization, how many types of hybridization, sp, sp2, sp3, sp3d, sp3d2, and sp3d3. These are the different types of hybridization. And we have elaborately discussed about sp, sp2, to some extent sp3 hybridizations. And hybridization is the core topic of chemical bonding, as it is great extent uh, the shapes of the molecules, the bond angles, and also to some extent the geometry. The shape is slightly different from geometry. I'll explain how it is so. Is well explained on the basis of hybridization concept. And before that, we learn a very, very important quality which makes us feel very disturbed. Can you make a guess what is that quality? Fault finding tendencies. Okay. So one should be faultless. The quality is one should be faultless. Should not be any fault. That means one should be perfect. So a very important thing. Practically it defines your efficiency. It defines your quality of heart. So faultless and also fault finding tendencies. No fault finding tendencies. Very, very important. This is one of the primary disease in this generation, particularly the age you are living, finding fault in others all the time. Yeah. So any situation, so our mood is to find fault in others. Okay. Yeah. And once you find fault, the next step is to criticize, right? So finding fault means judging with your tiny intelligence. You're going to judge others, whether it is right or wrong, right? So the most important thing is a wise person, if you are wise at head, so you try to introspect yourself. You try to find fault in yourself and make necessary corrections all the time. Very, very important. Yeah. Then you become faultless. So faultless means perfect. Yeah. So that is one of the quality. So becoming faultless is one of the quality. Anything you do, for example, you're speaking something, you don't slip your tongue. If you slip something naturally, you cannot take it back, right? And one more thing, the person who uh, you criticized, so he or she is going to take it to the heart. So definitely is going to have a serious repercussions, right? So your communication should be very, very important. It should be perfect. So when you are speaking to anyone, you have to evaluate, you have to think about the consequences of your speech. How you're going to, your speech is going to influence others. So whether in your speech there is a perfection or not, there is a truthfulness or not, there is a sincerity of purpose or not. Very, very important. Yeah. Your speech should not be hurting others. So when you find fault in others, so you are like this is the, so finding fault and all, you cannot do. Only father, mother, teachers, they have right. Because their mood is not to, because if you find fault, naturally you'll become very grudgeful, envious, your heart becomes polluted. And the people who rise above this enviousness are the people who have a non-envious lifestyle. Naturally, they never try to take to the heart. So they correct it for the benefit of, they do correction. So, which is beneficial to the native. It's pretty important. So, most of the times, if you observe, do you have a fault finding tendency or not? And are you faultless or not? These two questions are very, very important. Anything, for example, in mother, father, brother, sisters, okay, you're always finding faults. This is not good, that is not good. Okay. And yeah, you find fault in the college, the teachers. If you get less marks, and naturally, to cover yourself, to cover your ignorance, so to cover your indiscipline and sincerity, naturally, you try to just put upon the teacher has not taught. Okay. So enough time is not given. Something, some cause you convey. Try to understand. So you try to find fault in others. Sometimes, most of the times, to cover yourself. Very, very important. So finding fault is also a kind of uh, untruthfulness only. Yeah. Sometimes you become untruthful. You find a fault in others just to cover yourself. Very, very important. So that means you lose the transparency, right? You become translucent or opaque, okay? And people cannot see. So you should be a simple person. If you are a simple person, one will be very transparent. And if you are a very complicated mindset, so you can never be understood by anyone. Very complex mind. Yeah. And this fault finding tendencies, if you have, you are the sufferer. Because your mind will be, you can say it is clouded or crowded or saturated or flooded. So with a lot of these feelings, right? This is not good, that is not good. This person has done something, that person has spoken something. So something always you find faults. Very, very important. So fault finding is a disease. At your age, at least up to 30 years, till you become very matured. 30 years means there is a long way to go. At least half more life you have to, so you have to spend. So you should not find fault in others. When you don't find fault in others, you will become very peaceful. You'll become very simple. Simplicity of the mind also will come. So try to practice this wonderful quality of becoming faultless. So faultless uh, in your actions, particularly in your speech. Yeah, you should be faultless. Very, very important. And most of the time, we do mistake. Yeah. Because our thinking should not be too slow. It should not be too fast. It should be controller should be there, moderate. Yeah. Our reactions also should not be too fast. It should not be too slow. Slow is okay. Yeah. And be moderate. That's pretty important. Control the valve. Very important. So the control is very, very important. No need to react immediately. Yeah. With some uh, you have always something to defend, right? So if you do mistake, so accepting mistake is very difficult. Try to understand. In this world, um, getting a 80 seat or need seat is easy, but accepting your mistake is very, very difficult. When you do something, immediately the pride covers you that you are right, you are okay. So and you start giving a lot of explanation. Sometimes you defend most of the times. You never agree that you did mistake, that you are wrong, okay, and you are the wrong path. You are deviated. You never agree. So it's very dangerous quality. So these are the some of the problems. Relations are broken. Okay, why relations are broken? You never agree. You never compromise. Yeah, that is a stubbornness. Yeah. So this fault finding tendency is, if you have, try to understand. Naturally, you have two more things with you: pride, envy. These two things are with you. A person who is prideful and who is envious, and 100%, you can never be happy in your life. And 100%, you have very few relationships. Your relationships are not strong even if you have. Try to understand. You always walk into trouble, and mental sickness will come definitely. Prideful and envious person will be will be having a fault finding tendency, and is a very complicated personality. So they're all well related. So hope. So you understand the importance of faultlessness. That is, faultlessness is nothing but perfection. Perfection in your duties, particularly academic duties. You have academic duties. So in academic duties, it is full of blunders, mistakes, and faults. You are made up of sins. You are made up of mistakes. You are made up of blunders. And what right you have to find fault in others? My simple question. Okay. Have you not done any mistakes in your life? Yeah. Try to understand this. Still students are coming late. Right. I'm bearing it. Right. Yeah. Try to understand this. So don't become a, don't be a judge. Simple. Okay. Don't be a judge. Yeah. You're not capable enough to judge others and to give judgment. Okay. So when you take the position of a judge, naturally, so it's you, yeah, will be in trouble. Okay. Naturally, all this mental sickness will be developed. It's a sickness. Some people are there always, they find faults. I've seen many people. They find faults in others. And they don't find fault in themselves. That's the problem. Yeah. So try to understand. So if you want to become very puffed up person, with pride and envy, naturally you find fault in others. It is a very, very, very important quality. Should be taken very, very seriously. Not finding fault in others. Very important. Particularly elders. And nature also, whether you understand or not, whether you have a belief or not. When you try to find fault in elderly people, noble people, spiritually elevated people, their lifespan goes down. Very, very important. Not good. Hope with this note, expecting that you cultivate this quality of faultless in your personality, and also not having the fault finding tendency. So let us make a move with SP3 hybridization. Now, this already I explained to you what is hybridization is all about. It is a process of intermixing. Here, particularly SP3 hybridization means one s orbital and three p orbitals. They intermix and forms sp3 hybrid, forming a tetrahedral shape. See, one s orbital, one px orbital, one py orbital, one pz orbital. These are the three p orbitals. They become intermix, and these are the sp3 hybrids. So these four sp3 hybrids of a particular atom will form a tetrahedral shape, right? So I'll explain to you. So for example, if it is CH4, how to write? So these are the carbon, carbon elevated state, excited state. So excited state directly I'm writing. Okay. Sorry. Yeah. So here it is. This is the carbon excited state. This electron is excited here. Now, one s orbital, px orbital, py orbital, pz orbital. They combine and forms a sp3 hybrid for this carbon. See, this is sp3 hybrid like this. Now, to this sp3 hybrid, naturally, what happens? 4 hydrogens will combine. So each will share one. Okay. So they form hydrogen, 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 hydrogen. So it has tetrahedral geometry. And always in this tetrahedral geometry, the bond angle is 109 degrees, 28 minutes. So, hope you are clear. So this is the tetrahedral structure. Now, let us see an example. Another example. Now listen very carefully. Listen very carefully. For example, just now I explain one CH4 geometry. In CH4 geometry, there are 4 electron pairs like this. 4 pairs are there. EP. Bond pairs, lone pairs. If there are 4 electron pairs, all 4 are bond pairs. There is no lone pair. We have a tetrahedral geometry. TD, I am writing here shortcut TD. Let us take ammonia. Ammonia structure is like this. Here one lone pair is there. So, number of electron pairs are 4 only, including the lone pair. 1, 2, 3, 4. Bond pairs are only 3. See here, bonds are, how many bonds are there? 1, 2, 3 bonds are there. And how many lone pairs are there? 1 lone pair is there. And the structure will be pyramidal. sp3 hybridization only. Next, water you take. Water. Water molecule looks like this. So total electron pairs will be 4 only. Total electron pairs are 4. And 2 are bond pairs. You can see here. This is 1 and this is 2. Lone pairs are how many? 2 are there. Then you can see it is angular shape. So it got a V shape. You can say V shape. So very, very important point. When there are 4 electron pairs, all 4 are bond pairs. There is no lone pair. It is got a tetrahedral geometry. For example, CCl4. Tetrahedral geometry. Now, 4 electron pairs, 3 bond pair and 1 lone pair. It leads to pyramidal structure. You can see here there is a pyramidal structure like this. 1 lone pair is here. This is a lone pair. 4 electron pairs, 2 bond pairs, 2 lone pairs. So there are 2 bond pairs and 2 lone pairs. It got here bent geometry or V shape, or I can say angular shape. Angular. So here 1 lone pair gives rise to pyramidal geometry and no lone pair gives rise to tetrahedral geometry. So basic shape is like this only. But 1 lone pair is there naturally. So that this becomes a lone pair and you got a pyramidal structure. If 2 lone pairs are there, naturally, you got angular structure. Here you have a lone pair. So that's right. Based on the lone pairs, geometry will be decided. Any questions? Well, let us see ammonia molecule. First ground state configuration of nitrogen. 1s2, 2s2, 2p3. This is 1s2. This is 2p3. Sorry, 2s2, 2p3. Now, actually, ammonia, how many bonds are required? 3. Now, already 1, 2, 3, I got it. 3 hydrogens only are there. I don't need to excite. Not required. Excitement is not required. So, 1s orbital, this one 1s orbital, 3p orbitals of nitrogen gets intermixed. So, what are these orbitals? Atomic orbitals. So, the atomic orbitals, yes, 1s, 3p of nitrogen, they become intermixed and it forms 4 sp3 hybrid orbitals. So, these are the 4 sp3 hybrid orbitals. Now, what are these 4? Let us see here. Like this, I'm writing. 1, tetrahedral geometry. 2, these are the sp3 hybrids. Okay. Now listen very carefully. To this sp3 hybrid of nitrogen, hybrid, what happens? 3 hydrogens, they combine, right? 3 hydrogens, they overlap. So naturally, so there are 3 hydrogens. 1, 2, 3. 1 lone pair. That's it. So it got a pyramidal structure. Bond angle here, there is a problem. Actually, it should be 109 degrees, 28 minutes. So listen carefully. For example, in this methane, CH4, listen very carefully. All are bond pairs only. Bond pairs are directional in space. So with 109 degrees, 28 minutes. So here all are bond pairs only. Students, listen very carefully. So this is a bond pair, this is a bond pair, this is a bond pair, this is a bond pair. Now listen very carefully. This bond pair repulsion is very less. BP repulsion. BP means bond pair repulsion. So this bond pair, I'll just take another color. So this bond pair, this bond pair, this bond pair, this bond pair. So this is a BP repulsion, very less. Generally, BP repulsion is very less. So here, there is a LP and there is a BP. This is also BP. And there is a repulsion you can see here. Because these are non-directional in space. They'll move here, like this it will move. So there is a repulsion. This repulsion is called LP-BP repulsion, lone pair bond pair repulsion, which is greater than BP repulsion. Right to understand. This is very, very important point. So bond angle, because of this repulsion, this bond listen very carefully. These lone pairs are repelling the bond pairs. So to avoid, to overcome this lone pair bond pair repulsions, bond angle decreases. So bond angle will be decreasing like this. Earlier it was like this. Bond angle will decrease because of this lone pair. So the bond angle will come down from 109 degrees to 107 degrees because of which repulsion? Johnny Mahit. What is the repulsion here? Why the bond pair? Why the bond angle decreases? Is not there.
Sir, am I audible?
Yeah. Such important concept should not miss. Listen very carefully. Now, lone pairs offers lone pair bond pair repulsion. That's why the bond angle will decrease from 109 degrees to 107 degrees. I repeat this concept, listen very carefully. So here in CH4, all are bond pairs only. So naturally you experience bond pair repulsion in this case. But in ammonia molecule, there is one lone pair. Lone pairs are non-directional. So here we have a LP BP repulsion. This LP BP repulsion is greater than PP PP repulsion. That is the one of the reason the bond angle is decreasing from 109 to 107 degrees. Hope you are clear. Shilpita, you got a doubt?
Sir, yes, sir. Sir, when they ask the bond angle of ammonia, should we write the original 109 degrees or 107 degrees, sir?
107 only.
Okay, sir.
Bond angle of ammonia is 107, not 109. Because this lone pair will repel these bond pairs, right? So to avoid this repulsion, the bond angle decreases, which is 107 degrees only. Are you following? Here actually it should be 109 degrees. But because of the repulsion, it comes down to 107 degrees. I hope I am clear.
Yes, sir.
Now, as there is a lone pair, see, this is a lone pair. See, this is a lone pair. So we got a pyramidal geometry. So whenever there are four electron pairs, one lone pair, you always have a pyramidal geometry. Very interesting. Next. So there is a repulsion. These are the repulsions. Lone pair, bond pair repulsions. Mr. Praneeth. Mr. Praneeth. Mr. Praneeth.
Yes, sir.
You're supposed to come at right time.
No, sir, I got disconnected, sir.
Okay. Now, the other repulsions you can see. So because of the repulsions, the bond angle has come down to 107 degrees, 48 minutes. So this is the pyramidal structure. Can you see the pyramidal structure here? This is how it looks. Okay. Now, very, very important. Shape is pyramidal, but it is sp3 hybridization only. sp3 hybridization, percentage of S character is 25. Percentage of P character is 75. Right? Sigma bonds are 3, pi bonds. There is no pi bond here. Now, one lone pair is there, 3 bond pairs are there. Okay. Hybridization is this one sp3s because hydrogen is S, na? sp3s hybridization, overlapping. Water. So let us see water molecule. Water molecule is slightly different. Okay. So let us observe what is happening in the water molecule. So in the water molecule, we observe how many lone pairs? 2 lone pairs. I'll show you how you get the 2 lone pairs. Have a look. Let us see the ground state electronic configuration of oxygen because that is the central atom. Okay. 1s2, 2s2, 2p4. Outermost means what? Last orbit. Which is the last orbit? Second orbit. So 2s2, 2p4. That's why its valency is 6. Right? So this is 1s2, 2s2, 2p6. So last means, try to understand here. This one, only this. Consider this one. I'll write here for you. 2s. This only you should consider. Listen carefully. In water molecule, only 2 hydrogens are there. Right? So here one hydrogen. Finish. Right? Agreed. So that means no need of excitation. That is the meaning. I don't require any excitation here. Right? So S orbital, Px orbital, Py orbital, pz orbital. So these are all sp3 hybrids, forms sp3 hybrids. So these will gets intermixed and forms like this. Like this. This is the oxygen. The atomic orbitals of oxygen, they are the atomic orbitals. As per the definition of hybridization, atomic orbitals. Shortcut is AOs. They get intermixed and forms sp3 hybrid. This is the sp3 hybrid of oxygen. Hybrid. And now what happens? Two hydrogens will combine, right? Two hydrogens will combine. Now, when two hydrogens are combined, what happens? Mr. Shashidhar. Mr. Shashidhar. Mr. Shashidhar,
Yes, sir.
you are late.
Sir, I was having power cut, sir. I messaged you also, sir.
Okay, fine. Have a look here. Now, you can see there are two lone pairs. Only two bond pairs are there. Hydrogen here and hydrogen here. Now, there are two lone pairs. Two lone pairs. Right? This is the situation in water molecule. There are two lone pairs are there. Let us see if you have two lone pairs, what happens. Now listen carefully. Listen very carefully. I'm explaining here. Now this is oxygen. These are two lone pairs. These are the bond pairs. Okay. Now listen very carefully. Here this is hydrogen. This is also hydrogen. These are the lone pairs. Now in CH4, listen very carefully. CH4. There is a repulsion called BP repulsion. What is BP means? Bond pair repulsion. In ammonia molecule, if you observe, there is one lone pair here. So there is a lone pair bond pair repulsion. Do you agree or not? Lone pair bond pair
Yes,
repulsion.
sir.
Now if you observe here, this is LP and this is also LP. There is a lone pair repulsion is there. To your surprise, lone pair repulsion is both are non-directional. The repulsion is much more. So is greater. So always lone pair repulsion is greater than lone pair bond pair repulsion. It is also greater than lone pair bond pair repulsion. So here this is a bond pair. Here also this is a bond pair. Here lone pair is there, lone pair bond pair is there, bond pair is there. The repulsions are there. So lone pair repulsions are very stronger. That's why the bond angle decreases from 109 to 104 degrees. Because of why 104 degrees? There is a what type of repulsion is there?
Lone pair
Bond pair
repulsion.
repulsion, sir.
Lone pair repulsion is stronger than lone pair bond pair. So lone pair repulsion is stronger. So bond angle further decreases to overcome these repulsions. Okay, naturally. So for example, if teacher is beating you, you go away. Right. Similarly, these bond pairs will go away, go down. I mean to say to overcome these repulsions. That's why the bond angle will become 104 degrees. And here the bond angle becomes 107 degrees because there is a LP-BP repulsion. Here BP-BP repulsion, 109 degrees will be there. So this is so now based on the number of electron pairs, you can predict the structure, right? Hybridization and valence bond theory failed. Lewis theory failed in explaining the shapes or structures. Yeah. Now one important point I want to mention. Shape and geometry. Geometry is tetrahedral. Shape is bent shape. Geometry is tetrahedral. Shape is pyramidal. I hope you understood. Regular geometry is tetrahedral. But its shape is, because of a lone pair, its shape is. Now listen. So what is happening? The two sp3 hybrid orbitals of oxygen overlapping with one s orbital of hydrogen atoms. That's why it is forming, right? Water molecule. See, this is the hybrid of oxygen. oxygen. So this is s orbital of hydrogen, the two lone pairs, right? Two lone pairs. So repulsion makes the bond angle 104 degrees 31 minutes. This is all about sp3 hybridization. Naturally, water has what geometry? What geometry? You can say three things: angular, V shape, or bent shape. So you can write anything, it is right. So whenever there are four electron pairs, all four are bond pairs, no lone pairs, the geometry is tetrahedral. When there are four electron pairs, when there are three bond pairs, one lone pair, the shape is pyramidal structure. When there are four electron pairs, two bond pairs and two lone pairs, the shape is angular. Hope you are clear. You can see here. The two lone pairs, the repulsion, water molecule bond angle is the lone pairs, two lone pairs. So 104 degrees because of this lone pairs. So this is all about, so some of the examples. Okay. SCl2, OF2, Cl2, NH2, Cl2, ClO2 minus. Now, probably most rated episode I am going to cover tomorrow. Okay. Tomorrow I give shortcuts and a lot of models I'll tell. Don't miss tomorrow's class, you'll be in trouble. Yeah. Next. That is some MCQs. What is the percentage of S character in sp3 hybridization? Anyone? Percentage of S character.
25%, sir.
Yes, it is 25%. 25%. Naturally, P will be 75.
75%.
75, sir.
Yes. These are useful in future. Okay. What type of hybridization exists in ammonia and water?
sp3 hybridization.
SP3, sir.
sp3 and sp3, sir.
Both are sp3 only. Now, let us see the next one. So, apart from one s orbital, three p orbitals, one d orbital is also participating. So, in such case, you get triagonal bipyramidal geometry. So, there is a process of intermixing of atomic orbitals of a respective element, like phosphorus, PCl for example. So one s orbital, three p orbitals, and one d orbital. Phosphorus is having d orbital. Nitrogen is not having, oxygen is not having, carbon is not having. There are no d orbitals for carbon, nitrogen, oxygen, right? Yeah. Example, wonderful example, PCl5. You know, phosphorus. So phosphorus is the central atom, right? Let us see the ground state configuration. Can anybody tell me the ground state configuration of phosphorus? Nitrogen, phosphorus. Nitrogen is
3p3, sir.
good. 3s2, 3p3. Right? 3s2, 3p3. Now, there are d orbitals, right? They are the d orbitals. Now, listen very carefully. I had to, how many I require bond pairs? Can anybody tell me? How many chlorines are there? 5. For example,
5, sir.
I'll tell you one thing. You have 4 chairs. Okay. You have 3 chairs only are there, for example. So some guest has come. What you do? You arrange one more chair like that. 2 more guests. Okay. Similarly, 5 I require. But here, how many are there? 3 are there. It can share with only 3.
3, sir.
That's why you have to excite. Okay. You have to excite this. See, I excited. Can you see here? Excited this electron to here. Which orbital I excited? Which orbital I excited? D orbital.
P orbital, sir.
Subdelta to D orbital. Now listen carefully. Now 5 chlorines can be shared. Now 1s, 3 p orbitals, and when d z square orbital, they get intermixed. and forms so these are they get intermixed. They form triagonal bipyramidal geometry. Let us see here. I'll explain. First, I'll explain here. Okay. Now, listen very carefully. When s orbital plus px, 1 second. So on px orbital, yeah, on px orbital, on py orbital, and one pz orbital. Next, plus dz square orbital. They get intermixed and forms a hybrid. So the hybrid looks like this. I can write like this. This looks like this. This is a triagonal bipyramidal structure like this. This is a TBP, triagonal bipyramidal structure. Now let us see here in the triagonal bipyramidal structure. May I know here in a triagonal structure what is the bond angle? Can anybody tell me? What is the bond angle in triagonal?
SP2, sir.
Huh? How much?
SP2, sir.
No, I am asking the bond angle. Yes, it is a
Sir, 120 degrees, sir.
120 degrees is there.
120 degrees.
Now, if you see this angle, how much is the bond angle? 90 degrees. So there are two bond angles here. One is 120 degrees and this is 90 degrees. This is 90 degrees. 90 degrees. So there are two bond angles. Try to understand this. Okay. Now what happens? Phosphorus is the central atom. Cl, 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 Cl. This is how you get a triagonal bipyramidal geometry. Hope you understood. With PCl5 hybridization. Yeah. Now listen very carefully. First of all, in a triagonal bipyramidal geometry, these positions are called equatorial positions. The Cl, Cl, Cl. So because equatorial triangle, you remember, these chlorines are in axial positions. So these are called, listen very carefully. These are called axial bonds. This bond is called axial bond. So this bond is called equatorial bonds. So this much understanding you should have. So if sp3 hybridization, there are two types of bond angles. One is 90 and is 120 degrees. Already told you this is 120, this is 90. Two bond angles are there. So whenever there is a sp3 dehybridization, naturally, that's how I convert axial bonds, 90 degrees. So one s orbital, three px orbitals, and one dz square orbital, they get intermixed and forms a PCl5 structure. So these are axial bonds, these are equatorial bonds. You can see the bond. Can you see the bond angle 90 degrees in the 3 dimension? Can you see? Now
Yes,
there is
sir.
a bond. There is a bond angle between equatorial positions. Actually, this axial position is perpendicular. Now you can see in the 3 dimension. So this is trigonal bipyramidal structure. Why it is called trigonal bipyramidal? I'll draw and show you here. So this is trigonal. Now bipyramid. Bipyramid means you should draw the pyramid. See here. See here. Can you see a pyramid?
Yes,
Okay.
sir.
Can you see a pyramid now? So that's why bipyramidal structure. Hope you are clear. So axial angle, equatorial angle is 120 degrees. Axial angle is 90 degrees. So between two axials, you can see 180 degrees is there. Two PCL axial. This is one PCL bond. This is another PCL. 180 degrees. Angle between two axial bonds. So this is the explanation associated with. See, you can see here the 90 degrees. I'll show you one by one. This is 90 degrees. 90 degrees is between one axial and one equatorial. Equatorial is 120. Axial is 180. Okay. This is equatorial 120. And that is axial 180 degrees. So this is an understanding is associated with sp3d hybridization. Now, how many equatorial sigma bonds are there? Can anybody tell me? You soups respond. This is one PCL, another PCL here, another PCL here. How many are there bonds? Sigma bonds, 3 PCL bonds. Can you see here?
5, sir.
3, sir.
3
Three,
PCL.
sir.
Equatorial is asked actually.
3 PCL.
3 only. PCL,
Yes, sir.
PCL. Now, in between equatorial and axial bonds, which has more repulsive forces? Important. Very, very important. Now listen very carefully. These PCL equatorial bonds are what at what type of angle? How much apart?
120 degrees.
Very simple, very good. 120 degrees apart. So these PCL bonds are 120 degrees apart. Now this chlorine, this one, is how many degrees apart?
90 degrees, sir.
There is a repulsion. Very, very important. Very, very important. So this repulsion, can I say this one as this repulsion? This repulsion between one equatorial, PCL equatorial and PCL axial. This repulsion is 90 degrees repulsion. What is it? 90 degrees repulsion is there. Can you see here one more 90 degrees repulsion?
Yes,
Yes,
sir.
sir.
90 degrees repulsion is there. Here also. Can you see here one more 90 degrees repulsion?
Yes, sir.
How many
Yes,
90 degrees
sir.
repulsions are there?
4, sir.
4 90 degrees repulsions are there. So that is the reason to avoid the repulsion, these axial bonds are longer. Important. Now in PCl5, 2 types of bond lengths will be there. PCL equatorial bond length, this is equatorial. And PCL axial, which is greater? Which is greater?
Axial, sir.
Axial is greater. I hope you understood. That's why PCl5 is unstable. So it gets dissociated into PCl3 and Cl2. Hope you understood. Because axial bonds are longer. So my another question. Why axial bonds are longer in PCl5? Simple. Answer is there here. Because there are
More repulsive forces.
490 degrees repulsions. 490 degrees repulsions are there. To overcome the repulsions, naturally, these axial bonds becomes longer. Longer means what? They are weaker. Weaker means what? You can easily
Yes,
break.
sir.
So that's why they get dissociated easily. Interesting. Clear or not?
Yes, sir.
Good. So already told you, axial bonds have more repulsive forces compared to equatorial, because equatorial are 120 degrees apart and axial are 90 degrees only. So there is a 90 degrees repulsions, right? So I told you already. Axial bonds have been formed to be slightly longer and slightly weaker than equatorial. So PCl5 is more reactive. More reactive means it dissociates into PCl3 and Cl2. Very interesting subject. So now, which d orbital is involved? See, I require a
sp3 z square.
I require a
dz square,
dz.
sir.
Why dz square? Because I require
dz
like this.
square, sir.
I require like this, na. Lobes should be like this. This is a triangle. I want a robe like this, right? Yeah. I'll tell you some more interesting things for you. See, sp3. See, listen. sp3. Listen very good. sp3d. I'm writing like this. sp2 plus pd. sp2 means what? What will form? What shape? What shape?
Diagonal shape, sir.
Planar, sir.
Diagonal planar. So this PD will form in dz square, na? PD will form what shape? Bipyramidal shape. So it becomes trigonal bipyramidal. Very deep subject. Interesting, na? sp2 forms trigonal
Yes,
planar.
sir.
And this
Yes,
is PD.
sir.
This is PD. And this is sp2. This is sp2. This is sp2. And what is this bond? PD. Understanding?
Yes,
Yes,
sir.
sir.
Yeah, very, very, very interesting subject.
Sir, can you
Yes.
tell me what is the order of d orbital, sir? Like dz square and all.
So I require axial bonds, right? I require axial bonds here. So for that dz square orbital shape is like this. Am I right? That's why it will form. It will PD. When P and D orbital will combine, dz square will combine and forms PD here. Axial bonds. Yo, what is your question? Exact question, may I know?
Sir, like in subshell of d orbitals, what is the order, sir? Like in the first orbital, what is dz square or like that, sir?
It's not like that. Actually, zero is dz square. They are hypothetical only, na? They are hypothetical only. So -2 plus 2 or -1 plus 1. This will be dxy like that, dyz like that. This dz square. Are you following?
Yes, sir.
Yeah. Which orbital is involved in this?
dz square, sir.
dz square.
There is dz square orbital. How many PCl equatorial bonds are there?
3, sir.
3, sir.
3. There are 3 bonds. Axial bonds and equal bonds are respectively. What is the bond angles?
90 and 120 degrees.
So 90 and 120. Very good. Now, sp3d hybridization is not done completed because I explained when 5 bond pairs are all 5 bond pairs are participating in hybridization. So, but one lone pair is there, 2 lone pairs are there. If one lone pair is there, it is having seesaw structure. If 2 lone pairs are there, it is having T shape. When 3 lone pairs are there, it is having linear structure. That I am going to take up tomorrow. That's why tomorrow's class is important. Very important class. Now, sp3 dehybridization. Okay. Now what will combine? 1s, 3p, and 2d orbitals will be combining this time. Huh? Now listen carefully. Example SF6, sulfur. Sulfur, you know what is the hybridization? Ground state. Oxygen sulfur belongs to the same family, 3s2, 3p4. 3s2, 3p4. Now listen carefully. How many bonds are required, students, here? How many covalent bonds are required? 6 are required. Okay. How many can be accommodated here? How many can be
2.
accommodated? 2 only.
2, sir.
I require 4. So I can extract how many electrons here? 1, Two electrons
sir.
I have to excite.
2, sir.
Very good. So first excited state. So see here, this is the first excited state. Second excited state. Definitely, I require which excited state? Second excited state. Now 6 are there. So sulfur, you have to excite this s electron as well as p electron. So now 6 are. Now 1 s orbital, 3 p orbitals, 1 dx square minus y square and dz. Why you may ask questions, sir? Why? How do you know and all? Very simple. See, here the shape is that octahedral shape like this. Now d, listen very carefully. Dz square x square minus y square is like this. Are you following? So this x square minus y square can form like this, and dz square can form like this. That's why you should be little intelligent enough, wise enough to understand this. Now these will combine and forms sp3d hybrid. 6 sp3d d2 hybrid also will be there. So they overlap. Octahedral shape. The bond angle 90 degrees. Let us see. Okay. So I told you already, dx square minus y square and dz square orbitals will be participating in it. Now SF6 you can see here. This is the SF6 molecule. So I'll show you here. Okay, let me see. Let me check up. So bond angle, can you see the bond angle here? 90 degrees only. So here the bond angle is. So here have a look here. Octahedral shape, sigma bonds, pi bonds are 0. 1 second. I'll show you something here. See, 1 s orbital, px orbital, py orbital, pz orbital, plus dx square minus y square. Lobes are along the axis, x-axis, y-axis. This is dx square minus y square orbital plus dz square orbital. They get intermixed and forms a hybrid. This is phosphorus like this. Now sulfur, this is sulfur. Now 6 Cl minus, so will form octahedral geometry. Cl, sorry, F right, SF6 right. So this is F minus, 1 second. Yeah, now this is sulfur. Central atom is sulfur. Yeah, now this is sulfur. Like this it will form. And now 6 F minus will combine and forms yes F6 octahedral, giving rise to octahedral geometry with a bond angle 90 degrees. So this is how it works. Hope you are clear. So always sp3d2 hybridization leads to 90 degrees bond angle with the octahedral structure. So what is the correct order of bond angle here? Come on. What is the bond angle in sp? 180 degrees. What is the bond angle in sp2? 120 degrees. What is the bond angle in sp3? 109 degrees. So hope you are clear. Right? Agreed or not?
Yes, sir.
Yes, sir.
So sp, sp2, sp3, sp3d, sp3d2. This is what you have studied. Bond angle is 180, 120 degrees, 109 degrees, 120 degrees and 90 degrees, 90 degrees. This is what you have learned so far. Well, which of the following angle corresponds to sp2? Naturally,
120 degrees.
120.
120 degrees, sir.
Which orbital is used in oxygen to form a sigma bond with other oxygen in O2 molecule? Sigma bond is which formula? O2 molecule. O2 molecule is pure p orbital only. Hybridization is not required. Now, when two hybrid orbitals have a bond angle 120, percentage S character will be easy only. 120 degrees means what? sp2. sp2, what is the percentage S character? 33.5.
33.
33.5.
So this the hybrid state of sulfur in SO3 and SO2. So this I'll explain in the next session. Okay, SO2 and SO3 I'll explain in the next session. And I also explain sp3 b3 hybridization also I'll explain. Okay. So this 1 second. So here sulfur and SO2 and SO3 both is having sp2. Very surprising. We'll see in the next session. Okay. Like carbon is also having sp2. This also I'll explain. Again. Okay. So NO2 plus, NO3 minus, NH4 plus. This complex ions, how to find the hybridization, I'll give one formula, shortcut. So we'll see in the next session these things. So any doubts, please? No doubts. Okay. Thanks for bearing. Have a good day.